Okay, year 11, I'm going to go through angles of magnitude again because I think some of you were a little bit confused about how we were actually finding the values in other areas apart from the acute angle. So what I'm going to do is I'm going to do a couple of these ones here from question 1, and I'm going to go through them very slowly so that you can see how we work them out. So what I'm going to do is I'm going to start with one that's actually not there. I'm going to try and do an example question. So let's take sine of an angle, x, equals a half. Now we know how to find the acute angle of this. We can just inverse sine a half, and that'll get us the answer. So shift sine 0.5, and I get 30 degrees. And I know that that is correct because I know that from my exact value, where this is 1, this is 2, and this is root 3, and this is 30, and this is 60, and sine 30 equals a half. But here's where we need to be a little bit smarter. We want to look at just not the one answer, all the answers for a set domain. And for question 1, our set domain is 0 to 360. So it helps if we know what the curve looks like. So I'll just draw an axis. I'm going to draw the sine curve between 0 and 360. And I'm going to put in the critical points. So here's 360. There's 180. There's 90. And there's 270. And we see here, because it's a sine curve, it goes up to 1 and down to -1. Now we want to find all the values for which this curve hits a half. So we want to find when this curve equals a half. So a half is about there. And we go along and we hit here. And there it is. And we already know that. We already know because we've done the inverse sine, it's 30. But our calculator can only give us one answer. And we can see quite clearly there's another answer here. And if we were to continue the sine curve, it would go on forever, and we would have an infinite different set of answers, or an infinite amount of answers. But because we're restricted between 0 and 360, we're only concerned from here to here. There are only 2 answers. One we've already got, which is the acute angle. And the other one, well, how do we work it out? Well, we're very lucky in the fact that the sine curve is symmetrical, which means from here to here is the same distance from here to here. So from 0 to 30 means I just have to go 180 back 30. And I'm going to write that. 180 minus 30. So I'm going to get my 2 answers, 30 and 150. And they're all the answers between 0 and 360. I quickly double check. If I go sine 150, I should get a half. And I do. And if I go sine 30, I should get a half. Okay. Well, that's a sine curve. Let's make some notes about this, the steps that you need to do. So the first step is to find the acute angle. And the second step is to look at the curve So look at the trig curve for the set domain, because they're going to have a domain or have a parameter about how far you can go, because otherwise you have an infinite amount of answers. So we're going to look at the curve for the set domain and work out all the possible answers. And I'm going to write another thing underneath there in a minute so you can see how they do it. So there's an example question. Now let's do some of the questions that are here. Let's go to the first one, A, and we've got sine theta equals 0.35. Well, the first thing I have to do is I have to work out what the acute angle is. So I'm just going to go inverse sine and I use my calculator. So I go shift sine 0.35. And I want to know what that is in degrees and minutes. So I go 20 degrees, 29 minutes. So over here, 20 degrees, 29 minutes. But I know that that's not the only answer. So I quickly look at the curve. And by doing it this way, you get really good at drawing the curve. And I know that 0.35, that's 1. So 0.35 will take me, I'll get one answer there, and I'll get one answer there. Remember, we're only going 0 to 360, and 360 is here, and all the other values are below the x-axis. Now, we already know this answer is 20 degrees and 29 minutes. And this answer is going to be the same angle back from, what was that again? Back from 180. So my other answer is 180 minus 20 degrees and 29 minutes. So I get my calculator out and I've got it there. So I'm going to go 180 minus my answer. I get that, but I want it in degrees, minutes and seconds. And I get, what was it again? 159 degrees, 31 minutes. 159 degrees and 31 minutes. And they're the two solutions. So it is rather easy, but let's take another one because they are going to get a bit harder. Let's take the next one, B. And this is, cos theta equals negative a half. Cos theta equals negative a half. Well, what I have to do is I have to work out the acute angle. Now, sometimes your calculator won't tell you the acute angle. I'll show you an instance of that. But let's see what our calculator tells us. So first we'll just go theta inverse cos of negative a half. I'll write down what I'm doing. And I go shift cos negative, make sure you know negative 0.5, get 120 degrees. Okay, so it's not the acute angle. That is not the acute angle. Oh dear, what are we going to do here? Well, let's have a look at the cos curve. And the cos curve goes like that. So you can see why it didn't give us an acute angle, because it's a negative value. Negative a half is about there. Remember, 1 is here. So the first one it's given us is this one here. And that's 120. Well, if I remember back to when we drew the curve, these were just the same values for the acute angles, but negative. So really the acute angle I'm looking for, here's 60, here's 30, there's 90, that's 1, that's 2, and that's root 3. So the real angle I'm looking for is 60. The acute angle that we need, the acute angle is 60. Because 60 would have given it to us. That gives you, oh, well, that's badly drawn, so I'll just quickly fix that. Whoops. Let's undo both of those. There we go. So the acute angle, but I know at positive a half, I get that, which is 60 degrees. And this distance is the same as this distance from 180. So if I'd found the acute angle, what I could have written here, instead of writing 120, I could have worked out that the acute angle was 60, but it's negative. And where is a cos curve negative? It's underneath. So it's 180 minus 60. And that's what my calculator told me. So I get my 120. But look, there's another one. Here it is. Now, where is that? Well, the cos curve, like the sine curve, is symmetrical. So it's the same distance here. So it's 60 more than 180. That's why finding that acute angle is important. So it's 180 plus 60, which gives us 240. And then we check on our calculator and we go cos, first we get rid of that, cos 120. We're hoping for negative a half. Beautiful. And cos 240. And we get negative a half again. So we know we're right. There's no way you should ever get any of these wrong because you can put them into your calculator. Okay, so if you find the acute angle and it's somewhere in the next bit, you can just go minus 180 or plus 180. Okay, well let's put that up here. And we'll do a little diagram to help us. So naught, and we'll go anti-clockwise because that's the configuration that we're going to use. If here we find the acute angle, and it doesn't matter about the sign because we need the acute angle to find all the other bits. Now, if the curve is, if we can see that it hits a curve between 0 and 180, well, if it's less than 180, it's 180 minus whatever the acute angle was. And if it's a bit more than 180, well, it's 180 plus whatever the acute angle is. And we'll come back and we'll fill in that last quadrant because there's 4 of them between 0. And by the way, this is 270, and we go all the way around to 360. By the way, we're going this way, we're going around this way. To get that way, we're going anti-clockwise. So we'll come back and have a look at what happens in that 4th quadrant when we see a question with it. So let's go back. Now, I want to do one that's going to give me 1 in that 4th quadrant. So let's have a look at C. C. Tan theta equals negative 1. Well, let's see what happens when I put it in my calculator and go inverse tan of negative 1. So shift tan of negative 1. I get negative 45. What's going on? Well, let's have a quick look at the tan curve. Oh, a bit negative there. Yeah, because the tan curve starts at 0 and we have an asymptote there. It goes like that. And you need to remember drawing this, an asymptote there. And then it goes there, and that's your 360 point. So there's 360, there's 180. This point is 270, and this point is 90. Okay, well, why did it give me negative 45 when I inverse tangent? Surely it should have given me this point here. Well, if you think about it now, the tan curve in mathematics allows you to go along the negative values of the x-axis. So the tan curve goes down there, and your calculator just told you the nearest one. And here it is here. Oops. Here it is here. This one's further away. And that's actually quite helpful because we want to find the acute angle that's going to give us a value of 1. And it is going to be 45. I mean, I can draw the triangle over here. The acute angle we need, 1 root 2, is going to be 45. That's going to be it. So the acute angle is 45. Now we just have to determine where that 45 is in relation to the negative parts of the curve. Well, we've already got 1 point here. Now we know that the angle that gives us a ratio of 1 is 45, and that one's back from 180. It's less than 180. And we know from our diagram, so theta will equal 180 minus 45. So we get 135. But there's another one up here for the domain that we have, which is 0 to 360. Now where is that? Now, that distance is the same as that distance. It's easy if you look up there. You can see it really obviously there. Which is the same as this distance. Okay, so I go back from 360. So the other point is 360 minus 45, which gives us 315. And we go to our calculator and check. So let's go tan 135. We're looking for negative 1. There we go. And we go tan 315, negative 1. Okay, so let's go back here to this diagram we drew. If it's close to 180, if it's less, we minus the acute angle. If it's more, we plus the acute angle. And what did we just discover? If it's more than 270, or in this quadrant between 270 and 360, we go back from 360. So we minus it from 360. So you find the acute angle for the ratio. You don't care about whether it's positive or negative. You find the acute angle for the ratio. You look at the curve and see where that ratio is positive or negative. And then if it's in the second quadrant between 90 and 180, you minus that acute angle from 180. If it's in the third quadrant, so if it's in the second quadrant, you go there. If it's in the third quadrant between 180 and 270, you get 180 and you add that acute angle that gave you that ratio. And if it's in the fourth quadrant, you go to 360 and come back the acute angle. Because all these curves are symmetrical. They all follow those same rules. Okay, let's do one more before I let you go. Let's do F. So here we go with F. And F is 2 cos theta equals root 3. 2 cos theta equals root 3. Now remember, this is an equation, and that's 2 times cos theta. So we have to get that 2 onto the other side. So we'll just go cos theta equals root 3 on 2. Now, I can shift cos that, and I will, find the inverse cos of root 3 on 2. I go to my calculator, shift cos root 3 divided by 2. 30 degrees. Okay, so my acute angle is 30 degrees. And you should have known that, because you know your right angle triangle. Here's 1, there's root 2, there's root 3, and there's 2, and your 30 degrees is in there, and there's your cos. Okay, let's have a look at the cos curve. Here it is. Now we found the acute angle, root 3 on 2, here it is, and it's 30 degrees. That distance is 30 degrees. Now the other value, the other positive value between 0 and 360 is way up here. But I know that that distance is the same as the acute angle. So to find the other one, I just go 360 minus the acute angle, 30 degrees. So my answer, or answers, are 30 degrees and 330 degrees. Let's just check on the calculator. Well, first I want to find out what root 3 on 2 is. Root 3 divided by 2, 0.866. So now if I go cos 330 and I want to get 0.866, well, there it is. And I could do cos 30, but let's do it then. Cos 30, is it going to be 0.866? Yes, it is. All right. So that's the basics for finding these answers. I am going to do one more, and it's a little bit more complicated, and it's the last one there, J. Tan squared 3 theta equals 1. I'm going to do it over here. So this is J. Tan squared 3 theta equals 1. Okay. The first thing I need to do is I need to get rid of that square. I need to have just tan. So I'll square root both sides. And I get tan 3 theta equals the square root of 1. But remember, when you do the square root, you get 2 possible answers. You get a positive and a negative. Okay, well, tan 3 theta equals, square root of 1 is just 1, so plus or minus 1. Okay, if I go inverse tan, now to get rid of that tan, and I just take the positive 1, because it's going to give me the acute angle. And I go to my calculator, and I go shift tan of 1, 45. So the acute angle is 45. But I know there are lots more. So I'm going to quickly, my second step, look at the trig curve. And I draw it. And when I'm drawing these, I'm only doing a rough drawing, only so I can see what's going on. Hold on, look at this. I'm going a bit beyond what I need to. Well, you'll see why in a minute. That's as far as I should have needed to go because it's for a set domain 0 to 360. But this 3 is going to play an important role because I'm going to have to divide all my answers by 3, which means I'm going to increase the domain by 3. And 3 360s, 3 times 360, means I should go to 1080. Well, let's see. I don't think I'll need to go all the way to 1080, but we'll see. Because there's maybe a little trick you can do to help you. Keep going. And there's another whole curve, 720, and let's just stop there because I'm going to show you a trick. All right, so where are our answers? Well, we got the first one, 45. But we've also got -1, so we're going to get that. And remember, this is 180. So there's going to be 180 more. Oh, okay. Look at our little diagram. We're going to go 180 minus the acute angle. So let's put that in. 180 minus 45, because that'll give us a -1. Remember, it's plus or minus 1. So we've got to get all of them. And then we'll get this one up here. Oh, I don't even need to look. 180 plus 45. And then this one down here. Oh, 360 minus 45. Oh, and you can see that the next one is just going to be 360 plus 45. And then the next one, oh, if only I knew that. Well, it's halfway between 360 and 720. Or 180 up from 360. Well, let's double check. 180 plus 360. 540. Oh, well, I'll just do the same thing because it's the same distance. So the next one will be 540 minus 45. And then 540 plus 45. And then 720 for this one. So I've got that one, minus 45. And I'm going to stop there because I'm going to show you something. So watch what happens. So here we go. We get 45. 180 minus 45 is 135. 180 plus 45 is 225. And 360 minus 45 is 315. 360 plus 45. Oh, well, that's 405. 540 minus 45, well, that's 495. 540 plus 45, well, that's 585. 720 minus 45, that's going to be 675, I think. I'm just going to check that one. 720 minus 45. Righto. Now that's not all of them because we know we're going to have to go all the way along here. But that's what 3 theta equals. All right? Now, here's the interesting thing. We know the period. We know the period is 180. So between these two roots, between every second root, there should be 180 degrees. Oh, yeah. Ah, yes, there's 180 between there and there. If you're not sure, trust me, 315 minus 135, 180. Okay. But even better, when you get these 4 roots, the next roots will be 360 more because you're going into the next 360. So let's just write them underneath. So 360, oh, that's easy. That's 405. 360 plus that, 135 plus 360, 495. And there it is. 360 plus that. 3 is going to be 585. Oh, there it is. 360 plus that. Well, 675. Then to go again, we just go 360 plus each one of these. So 360 again will give me 765. 360 plus that, well, I'm going to need my calculator for that, 495 plus 360, 855. And I'm going to do it again, 585 plus 360, 945. And the last one, 675 plus 360, 1035. So once you find the first 4 roots, or even the first 2, you can just, if they're in this case, you can just add 360 to them. Now, why did I do that? I'm well and truly out of the domain that is specified. I should have stopped at 360, but as I said, because of this 3 here, I'm going to have to divide all these by 3, and that'll bring them all back. It'll bring them all back. 45 divided by 3, that's easy, 15. 135 divided by 3. 135 divided by 3. Oh, 45. I'm beginning to see a pattern here. 225 divided by 3. 75. Oh, these are just going up by 30. Yes, because they would not, well, the gap between the 2 is 180. So the gap between the 2 now, if I divide by 3, will be 60. This gap here is just 30. So let's have a look at the next one. It should be 60 more than this 45. It should be 105. Let's just check. 315 divided by 3. 105. Now, these should go up by 360 divided by 3. It should go up by 120. Let's just check. So my feeling is that 120 plus that is 135. But let's just check. 405 divided by 3. Ah, 135. 495 divided by 3. 165. So they're going up by 120. Let's write this one in before we do it on our calculator. 120 plus 75 is 195. Let's just go 585 divided by 3. There we go. Well, now we can see the pattern. 120 plus 105, 225. 120 plus 135 is 255. 120 plus 165 is 285. 120 plus 195, 315. I think I'm going to double check that. 195 plus 120. Yep. And 120 plus the last one, 345. They should be all our answers. There are 9 of them. That's incredible. Sorry, 12. Because I get 4 answers from 0 to 360, plus another 4 from 360 to 720, plus another 4 from 720 to, 1080. And they all fit the domain because I have to go that far, because in the end I'm going to divide by this 3. Imagine if it was 4. I'd have to go all the way to, 1,440, I think. So they're your ones. But once you get the first 4, you can just add 360 or divide. It's going to be safer if you do it that way. And get the other remaining ones for however many repeats you got to do. That was really hard. But let's double check. Now, I'm not going to double check them all. So I'm just going to take one to double check. So I'm going to take the 285. And I'm going to put it back into the original equation to make sure it works. Now, the original equation is there. Tan squared 3 times theta. So let's go. Get our calculator. So first thing I'm going to do, I'm going to put a bracket because I'm going to square it. Tan 3 times 285. Close that bracket. Close the other bracket. Now I have to square that. Now that should equal 1. Well, brilliant. I can use my back arrow to double check. Why don't I try 345? Well, that equals 1. Let's try one more. Let's go back and try 165. Okay, so I'm pretty sure I'm right. So let's recap. What do you need to do to solve these questions of angles of magnitude? First, you've got to realise there's more than one answer. You need to realise that there are going to be more than one answer for the domain. Find the acute angle that gives a ratio. Don't worry about whether it's positive or negative. Find the acute angle that gives you the ratio. Then look at the trig curve for the set domain. Now remember, if you get a number in front of that, you're going to have to either double it. So down here with these ones, you're going to have to double that one, triple that one, double that one, and triple that one. Look at the trig curve for that set domain and work out all the possible answers. All the possible answers. Usually there'll only be 2. If it's positive and negative, there'll be 4. If it's in a bigger domain, they'll double, like if it's a 2 in front of it. If it's in a bigger domain, like 3 times, there'll be triple, and so on. I doubt very much you'll get anything more than a triple. And then use this little skill you have here, this little thing for going 180 minus, 180 plus, 360 minus. But that only works from 0 to 360, which is why it is important, like in that last one, to look at tan beyond 360. All right, that's enough. You need to go and practice them. You need to get question 1 done.